Matt Wagner here from Insource Renewables out of Pittsfield, Maine. This morning we're at my house to talk about electrical efficiency and some decisions that you can make to kind of lower the cost of your PV by selecting energy efficient appliances and water pumping solutions and lighting. So here we have, this is my like a 1.8 kW system. As you can see, it's pole mounted, and it's a beautiful solar day here in Knox. I'm going to bring you guys inside my house here, which is buried in snow, and we'll talk about some lighting and water pumping and water heating and blah blah blah. Alright, so folks, we're going to bring you into the house, and we wanted to do a quick background here. This house was originally about a 22 by 22. It's really well insulated, 5.5 inch thick foam walls on the original part of the house and 6 inches of foam in the ceiling. We used to heat just that part of the house with about a cord and a half of wood a year. So it's pretty energy efficient, and as you can see in the back, this past year with a couple of kids, we decided to add on, and it looks like this year we're going to be burning about 2 to 2.5 cord of wood. So pretty good. The new part of the house is dense packed cellulose with 1.5 inches of foam on the outside and loose filled cellulose in the attic. It's not super insulated, but it's very well insulated, I'd say. So the house used to be off-grid for about 8 years. My wife and I lived here with a battery-based system that ran just about everything we needed: our well pump, washing machine, and hot water heater. We did have a generator backup, but that entire system was based on a 200-watt solar electric array. That's 200 watts. Now we're up to close to 2,000 watts, and that does all of our electrical needs. Come on inside. Alright, so what we're looking at here is a house that was built with energy efficiency and a low-cost electric bill in mind. What we do mostly is we're coming into houses that weren't designed necessarily with energy efficiency in mind, and we're trying to work with homeowners to make their houses as energy efficient as makes sense. Some of the things that you can tackle to lower your electric bill are going to be dealing with your lighting. If you have old incandescent light bulbs, it's short money to just replace those with LEDs. The new LEDs do put out a fairly decent light, or compact fluorescence. Water heating, if you have just a regular old resistance-based electric water heater, it's very cost effective to just upgrade that to either a heat pump water heater or a solar heating system or an on-demand unit. There's a lot of options available for that, and I'll show you in a minute what I have. If you do have a well pump, if you pump your own water, there's some great options out there for well pumps, but you have to be looking for them before your well pump fails, on Thanksgiving Day. Because what's generally just available isn't the most efficient option. So let's just take a quick look. What we have here are dimmable LEDs up in the ceiling. They are retrofit light. They go into a regular 5 or 6 inch can, and I'll go ahead and turn them on. And they do dim down pretty far, and they also provide pretty nice light. So a lot of this stuff you can do yourself. I actually purchased just these Ecosmart Lights at Home Depot. I think they were like $15 a piece, and they replaced these light bulbs that I was using during construction. I think I paid $12 for 10 of these. And this is a 65 watt light bulb. And what I replaced it with was a 12.5 watt light bulb, which is a pretty considerable savings right there, over the life of the light bulb. This is marketed by these folks as saying that it's going to save over $200 over the life of the light bulb in electrical costs. So obviously replacing that light bulb makes a heck of a lot more sense than powering an inefficient light bulb with solar electricity. We're going to haul you guys down to the basement and show you guys some of the mechanical stuff going on down there. Alright, so what we have here is the kind of little mechanical corner of my basement. And there's a few things here that reflect some decisions that were made. One of them is a fairly large expansion tank for the well. And what this allows my well pump to do is to come on and run for an extended period of time and then shut off, so I have a lot of water storage, because it's the power cycling of the well, the turning on of the pump, that actually draws the peak amperage of the pump. Running the pump uses less electricity, so investing in a bigger tank can make sense. We also use a Rinnai on-demand water heater to heat our hot water. This unit only draws about 2 watts of electricity when it's in standby mode. It draws 120 watts of electricity when it's running. And right on the display, you can actually control the output water temperature. You can make it go up or down to meet your needs, so you're not dumping cold water into your heated water to make the water temperature that you want at your point of use, if that makes sense. I can also control this Rinnai from a remote control upstairs on my bathroom wall, and I'll show you that in a minute. Alright, so this is my string inverter. This system's about 8 years old, I'd say. And this is a 2,000 watt inverter made by Fronius. And we can open it up here and we can take a look and see what all is actually going on out there today. So right now we're producing just over 1 kW an hour, is what it looks like. And take a look at what we've done for total. So since I installed this, we've put up about 7.7 megawatts just on this small system alone. So over time, the amount of power that these produce does really add up. Alright, so in the little washroom here, as you can see, wife and I invested a long time ago in some energy efficient washer and dryer combo set here. This one happens to be an LG. There's plenty of makes and models out there. So what we have is a washing machine that draws about 4.5 amps. So it's a low electrical load, but it also uses less water. So you're also saving money on the amount of money you spend either on water and sewer fees if you're on city water, or on water pumping if you have your own well. We also use a gas dryer. It's more efficient than an electric dryer. Or it was at the time that we installed it. That may no longer be true with the rising cost of propane. Alright, so we were down in the basement and we were looking at the Rinnai on-demand water heater. And so here on the bathroom and kitchen wall, the shared wall here, I can also control the water temperature at the point of use. So if I'm going in to take a shower, I can turn it up to 120 or 115 if the kids are going to take a tub. And if I want to wash potatoes, you know, I can turn it right down to 98, so I'm not wasting any energy. So this is a very energy efficient refrigerator. It's about the most efficient one on the market. And again, you know, it's not necessarily for everybody. This is a countertop depth model. They're popular in Europe. This one is a US made refrigerator. It's made by Summit Professional. They make a lot of commercial appliances, but they also have a residential line. And you will actually find them to be fairly available. This unit has a freezer on the bottom, which we can open this up. And you'll see it's a fairly small freezer, full of the number 2, the letter N, we have Z, X, and the number 1, and coffee. This unit only draws 1.5 amps. So it's a very low electrical consumption. It costs about $28 a year in electricity to run. So this is the sort of investment, you know, this refrigerator cost around $1,100. This is the sort of investment you might want to think about making, you know, in the near future, because the cost of replacing your refrigerator is probably less than installing solar to power the one that you currently have if it's an older, inefficient one. So we see this a lot with people with electric bills that are over $100. A lot of the times we'll design a system that's smaller than what you're currently using, and as your appliances fail or as you want, you can replace them and step up to the more energy efficient units that are now on the market, and that'll maximize your investment in solar. So we talked about some of like the big 5 energy consumers nationwide are going to be space heating, refrigeration, water heating, televisions, and lighting. So we covered most of those. Space cooling, nationwide, that's about 20% of all the electricity used in the country. Maine, if you're in Maine, we really don't do a lot of cooling, although, you know, that is trending upwards. And that is also a benefit you can get from heating with a Fujitsu or a Mitsubishi mini-split heat pump. Those units take 1 unit of electricity and produce about 2.5 units of heating. They're more efficient than that when they're used for cooling. They do this by using electricity to transfer heat, not make heat. So the electricity is used to run a refrigeration system that basically transfers heat, extracts heat from the outside air, even at below 0 temperatures, and conditions your space. So if you are running air conditioning or electric-based heating, a mini-split heat pump is definitely something you should be looking into. And we've gone over lighting and water heating options. Televisions and media equipment, computers also use an incredible amount of electricity. One of the only ways that you can really prevent them from using electricity when you're not using them is, unfortunately, to unplug them, and a lot of people just don't do that. But turning them off when they're not in use is an important thing to do.